This said, I would like to welcome you again to the conference. You have now 2 exciting days ahead of you. And from now on, I would like to switch to our first keynote speaker, Erik Schultes. I'm pleased to introduce him. Erik is from the Leiden University, and we have known each other for many, many years now. We jointly worked on the Go Fair initiative. That was an initiative triggered by the Netherlands, France, and Germany. And imagine what the purpose, the objective was to establish the FAIR principles in Europe. When we had the first FAIR workshop at the University Library in Göttingen, I think it was in 2017, everybody was feared and reluctant to join. They did not understand what the purpose is. So we had to somehow, communicate, share the principles. They thought it's like in competition to their disciplinary standards for metadata. This was not the case. They thought it was like in conflict with the open science principles. This was not the case. And the Go Fair initiative, jointly financed by the 3 mentioned countries and nations, the purpose there was to spread out the idea of a FAIR in Europe. And Erik was a key leader from the Leiden University together with Barend Mons in these activities. Today, Erik is a senior researcher at the Leiden University in the Academic Center for Drug Research, and he is still engaged in the Go Fair Foundation, where he is a leader for the what is it called, the 3-point verification framework, right, Erik? That's an important result he achieved over the past years. That's a framework offering a structure route to implementing FAIR data and services. And today, Erik will talk about the relationship between the FAIR movement, the FAIR principles on the one side, and of course, artificial intelligence. Thank you very much, Erik, for being with us. And now the floor is yours. Thank you and enjoy the conference and, more important, the keynote.
Thank you very much, Klaus. And I would like to thank you and the organizing committee for the opportunity, the invitation to speak here. This is quite an honor. And I take it as a foregone conclusion that FAIR can empower open. So I won't actually be talking explicitly about open in my keynote, but I assume that FAIR is there to power open science. And I was asked indeed to speak about this relationship between FAIR data on the one hand and the emergence of readily available and very powerful AI systems on the other. So this is the basis of the presentation today. This is a complicated topic. FAIR is complicated. AI is certainly complicated, and we're trying to bring those together. So it's a bit of a dense keynote. I think usually keynotes are higher level, but I think we have to we have a number of things we have to address if we really want to begin to understand the relationship. So let's see if yeah, and I should say yeah. So I will present some high-level theoretical things, but also some practical things that we're doing in Leiden to show this connection between FAIR and AI. Back, in fact, in 2017, when FAIR was still a very new idea, the lead author of the FAIR Principles paper, Mark Wilkinson, used to show this slide, and I stole it from him. I would use it as well. And it was sort of this hypothetical. Imagine we lived in a world of FAIR data. What would that look like? How would that be different than what we do now? And so Mark said, here's a kind of a query that you could ask in a world that was FAIR. You could say, find me all known low molecular weight inhibitors of the human P65 protein. Separate that list based on inhibitors that are found in curated or peer-reviewed sources from those that are just kind of self-deposited. Keep track of the licensing and citation because I might want to reuse some of this in my research. And if some of these inhibitors are not openly available, then let me know. What do I need to do to get to access to those things? The idea was that FAIR was supposed to enhance the ability of machines to do the F, A, I, and R, to operationalize those functions, enabling a question like this to be handled more and more automatically by the machine. You could imagine a data steward doing this manually, but we thought the machine should do that. Right? Those are routine operations. What Mark was asking for is a list of inhibitors, and then some maybe identifiers to give you exactly the right inhibitor and the other information. Mark was not asking for a list of papers, 500,000 papers that you could read and look for in the inhibitors. Mark was not asking for data sets. You could do a Google dataset search and get 56 data sets, but then you have to parse those data sets. What Mark wanted was a list of inhibitors from that query. And at the time, we thought, well, even though this is a very complicated query, it could be enabled by relatively small amounts of metadata. And so I'm just showing a hypothetical metadata schema that would actually empower that question. You could get the results if this very lightweight metadata could be provided on published inhibitors. In 2024, with the rise of LLMs, I could cut and paste now this query into a chatbot, and I couldn't get an answer. Right? So from 2017 till now, we got to a point where we could actually begin asking this question directly. ChatGPT 4 came back with this response. So it clearly understood the question, but I don't yet have the list. Right? I'm getting an answer, but not a list. About 3 weeks ago, I asked ChatGPT 5, and I got the list. And I got identifiers, I got the source, I got the licensing, I got the contact info, and I got the citation in the tabular system. So ChatGPT 5 understood that question and went out and did the FAINR. So the question is, what does this mean for fair? Have the machines become so intelligent that we now obviate the need to make data explicitly fair? And I would say no, that's not the case. Going back to the definition, the FAIR guiding principles were to enhance the ability of machines. So the claim would be that if data were fair, if the metadata around inhibitors were more fair, you could get a better list. And in fact, if you look, there's some incomplete things here. The first inhibitor doesn't have an identifier, for example. So it's a bit of an inference. So we could sharpen the capabilities of AI, maybe make them more trustworthy in a scientific context, if the data were fair. We can also look at the problem the other way around. AI, more and more, is being asked to generate or to help us create fair data. This is a paper I published about 2 weeks ago. It was with a company called Sense Science. They're a spin-out or a potential spin-out from Frontiers Publishers. They have a tool called Fair Square, and that tool has an LLM called Clara. And the Sense Science platform is meant to verify your data set automatically. And so we ran a pilot with Sense Science. We handed Clara the master's thesis from my student Max and tabular data that we generated at the Leiden Academic Center for Drug Research. Clara did the rest. She wrote a 10-page article that has now been peer-reviewed through normal peer review channels at Frontiers Bioinformatics, and it passed. Right? So we have a peer-reviewed article that was entirely written by the AI. Checked by us, but entirely written by the AI. There's a data portal, an interactive data portal. We can actually get to our data and work with it. There's a Jupyter notebook that Clara wrote that's freely available if you'd like to expand on the Jupyter notebook. And there's even a podcast. And I was a bit skeptical of the podcast, but I actually love it. It nailed the nuances of our scientific investigation better than I could. These two American voices talking back and forth. But it's really, I think, very nice. So there's some links. You can check out what it is. But now here's a case of AI presenting, publishing our work in a fair way. in fact, in a complete narrative article. So what does all this mean? We have information that could go into the AI. We have information coming out of the AI. What we need are AI that we can believe in, that we can trust to handle our scientific information. So here's, the logic as I see it now. The AIs that we have been built on legacy data, which is not fair, not particularly fair. There's noise, there's inefficiencies in this, there's all kinds of biases. We know there's massive copyright violations, right? Any of the metadata around usage and reusage has been completely ignored with big consequences. The idea would be some of this information, a much smaller amount, could be made fair through some kind of verification process, could be machine ready. That could then enhance the AI, making the AI itself more trustworthy. That trusted AI could then better do the F, A, I, and R later on. It could also make outputs themselves fair. Right? So what comes out of the AI should also be fair, automatically fair from the source. And that trusted AI might even be entrusted to verify legacy data at scale, right? In a way that would be much faster than humans could do. All of these are positive feedback, virtuous cycles. More fair data, more trusted AI. More trusted AI, more fair data. And there's these two directions. There's AI-ready data, fair data, that can help the AI. And I would say there's also fair-ready AI that are generating fair data. So the proposal here would be that fair data can become itself a standard for both AI input and output. And trusted AI should consume and produce fair data. So AI-ready data is for fair AI inputs, and fair-ready AI will be creating AI outputs, fair AI outputs. Okay, so let's maybe see what this would look like in practice. There are today lots of emerging technologies around fair, systems that will handle some set of fair principles or another in different ways. We have been focusing more and more in Leiden on this idea of a fair digital object approach. I happen to be co-chair now as well of the Fair Digital Object Forum. We have a meeting in Vienna next year. You're welcome to come. But we also published an article last year showing an equivalence between the nanopublication framework and FDOs. And in fact, we believe that an appropriately structured nanopublication is equivalent, is compliant to the specification of an FDO. So if you do nanopubs in a certain way, you're doing FDOs. And we're going to use that as a basis for how we can show the relationship between fair and AI. So I'm going to say that nanopublication-based FDOs, fair digital objects, could be the standard input and output for trusted AI. And we're doing more and more work. There's different groups now in Leiden that are pursuing different avenues. So we're starting to think maybe we have something like a Leiden laboratory for nanopublication emerging, LLN. So first, let's talk about the AI-ready data as an input for trusted systems. So I work at the Metabolomics and Analytics Center. It's basically a high-throughput mass spectrometry laboratory. So samples go into these machines, human biosamples, for example, and the machine will separate out the metabolites, low molecular weight compounds, and profile the metabolism of the patient or the subject. We want to make that laboratory fair and AI ready. We want agentic AI systems to help us manage this laboratory and connect to the knowledge out there. So let's use nanopublications for this. This is a standardized information format. It uses open standards. Everything's machine readable using resource description framework and controlled vocabularies. FAIR is orchestrated in nanopubs on an existing nanopublication server network. That network has been there for about 10 years. It's decentralized. Anyone can put up a node. And at any given time, there's 30 or 40 nodes, I think. And that network runs a whole series of services that do things for nanopublications. You can publish, you can authenticate, you can get time and date stamps, you can get persistent identifiers for things, you can store your nanopublications, and you can search on them. So it's an open and decentralized network. No nanopublication has been lost in the last 10 years. So we said, okay, because this technology is relatively mature, let's use it. Let's use it to show what FAIR looks like in the context of our laboratory. The assertion of a nanopub is basically anything you want to say about the world. In this case, you could say low levels of 25-hydroxy vitamin D are linked to hypertension and diabetes. It's just an assertion. Could be true, could be false. There's probably evidence behind it, but someone was willing to say this, and we know who that person is. There's provenance attached, so we know who said it, when did they say it, and you could put other metadata in there as well. A third party may come along and republish this assertion in the form of a nanopub, this container for this assertion. All this information gets cryptographically hashed to become the identifier of the nanopub. So I'm showing a fingerprint. We can fingerprint these documents. If anything should change in the nanopublication, you would get a new identifier. So there's a kind of a blockchain quality to it. The assertion was meant to be anything. It could be a claim, a hypothesis, evidence, data. It needs to be a single semantic unit, though, just one thought. In our laboratory, we're going to use the assertion to capture metadata, FAIR, machine actionable metadata. And that's going to have a very simple format. That metadata is going to point to a digital object and its location. It's going to tell us what type of object that is. And then this ultra minimal type-specific metadata about it. And again, this will bring us into compliance with the idea of an FDO. So this is an example of an FDO. Okay. So here's what this looks like in practice. Here's a metadata description for a data set, a digital object called data set. It has a type, there's a location, and other things you would want to know about a data set. We can do this for a method. Our laboratory has methods and protocols. We can do this for articles. We can republish metadata on articles, and now we can have an overview of where our articles are. The publication info captures information about who created the nanopub. That would be a governance group that we're setting up in the laboratory. It's me and a postdoc, Ellum, and a graduate student, Max. And we're working together to curate these nanopublications on behalf of the 80 or so people in the laboratory. There's interfaces to these nanopublications at a platform called NanoDash. You can build an interface to the server network as you like. So we're not restricted to NanoDash, but we use it now. So there's 7 nanopublication types that we've created for our laboratory. And this is what they look like. They're basically a web form, right? You fill in the blanks, push a button, and you publish your nanopublication referring to a particular digital object. You can also query. There's Sparkle query tools, but you can build your own query engines as well. And with another group in Leiden over the last year, we've created what we call the FAIR Funder Framework. And this is a collection of nanopublication types that would be useful for funders. This is from the funder's point of view. And so there's administrative metadata on projects, and there's scientific context. And we decided to use these 7 nanopublication types in our laboratory. So here's what it looks like. Here's our laboratory. We have projects coming in, clinical trials. We have lots of human samples. we process the data, and we end up with a published data set. And along the way, we generate lots of documentation on that. We want to make nano publications of types that refer to this documentation trail. We can build a complete provenance train for each and every experiment and each and every sample. We build a knowledge graph that represents all the day-to-day activities in the lab. Some of the documents we create are restricted. They cannot be made open. Others we can make open kind of in real time. So our nano publications can point to each. And where we store our digital objects is, it doesn't have to be in a central location. We're using the open science framework now, but we're entertaining the GitHub. But we're also very interested now in the RAISE platform from EOSC. I think this could be a perfect solution for storing our documents while the metadata is stored in the nano publication server network. What does this enable? What would this look like? So we could do interesting things with this very minimal metadata, things that our laboratory would find like unbelievably useful. So just a simple questions. Find me all the data sets that were published in our laboratory in a certain time period. Or find me all the articles that were published by one of our lab members. Wherever those articles may be, I need all the methods that were developed in a particular project. And by the way, we have colleagues in a consortium who are also developing methods. So we might want to find their methods too. Find me all the instrument logs related to data sets published this year related to another project. All these kinds of questions can now be readily made, which we don't have answers for at the moment. We don't have a search engine that can answer these very basic questions. It's a manual job. Find me all the data management plans for projects related to hypertension. And maybe some of those DMPs could be found outside our laboratory. We have a very interesting conversation now with the University of Michigan who might want to replicate this nanopub approach in Michigan. So what it comes down to basically is that a human user can query in a very lightweight way the knowledge graph that we're creating for our laboratory, getting to these very simple but right now impossible questions. But being AI-ready metadata, an AI agent can now understand exactly what's going on in our laboratory, precisely, right? So we can communicate with our laboratory knowledge graph through an AI. That's what we're doing in our lab. I have colleagues at the university, at Leiden University, at the library, and also as the faculty data steward. This is Christina Hetna and Alessa Gambardella. And they're using nano publications kind of university-wide. They're running a pilot now called Leibniz, where they're using metadata tags for project, data set, and the major claims of your research article. And they're going to different researchers throughout the university and asking if they would want to participate, publish some metadata like this. The idea would be, Leiden University could ask for the first time, find me all the data sets that we published in the last year as a university. Again, right now, that question is impossible to answer. There's no search engine that will give you that answer. But it's a question of great importance to the university. So this is a way to approach that. That was all about AI-ready data, AI-ready information going into the AI. But what about this other aspect where AI begins to create fair metadata? We have another project that we're running at the moment called the Fair AI Attribution Project. It's through the SIDN Foundation. This is the group that owns .nl, right? So they're a very interesting internet advocacy group in the Netherlands. The FIA project is meant to create minimal metadata tags that recognize the contribution of AI in the creation of content. And so we have a very high-level schema where content could be fully human-generated, or it could be fully AI-generated, or something in between. I was just talking to Peter and Klaus. In the little bit of research I've done, apparently it's claimed most of the internet today is already AI generated. And it could be that by next year, the vast majority of the internet becomes AI generated. So the human created content on the internet could become the vanishingly tiny fraction of information. But this is of incredible importance to AI companies because they want to train their next generation models on human generated content, not AI generated content. And there's no way to decipher now. The cost of production of AI content is near zero, and it's such a high quality that we're flooding the internet with all kinds of great content, but it's not human created. This is a more detailed view of the FIA schema. And we're working in this project with a little company called Lyceum. I could urge you to take a look at what they do. They are a very interesting interface, kind of like NanoDash, but for metadata, for rights holding, for opt-out. It's a commercial company that's built mainly for commercial content producers like photographers or writers, etc. But we're using their technology, which involves fingerprinting technologies, to create these FIA tags, and there will be a nano-publication version of this as well. So the first thing we should do is tag my research article from Clara as being entirely AI generated. Right? That's a way this could be used. My colleague Sylvia Ledevidek at the LACDR runs the Cell Observatory, so it's a microscope facility. They're creating huge amounts of image data, microscopy image data. And she has a very nice project right now called Biocodes, which is in fact using the Lyceum platform to actually process metadata tags as kind of this immutable provenance trail on microscopy images. And if you know, microscopy images are incredibly easy to fake with AI, and the publishing industry now, academic publishers are terrified whenever they get microscopy images in a manuscript. They have no idea, they have no clue what's the source of those images and if they can believe them. So here we are documenting and bonifying the images at the source in the laboratory. So that was an example of, here at the end, of AI systems being able to indicate the content that they create as being AI generated. So with that, I would like to say thank you, and I hope there's enough time for questions. Thanks.